Today we are going to see an important topic in communication networks. That is Unit 2, Data Link Layer. The topic is High Level Data Link Control. That is HDLC. Is a protocol that's mostly widely used in today. We can see one by one. The HDLC was defined by ISO. It can be able to use for both point-to-point communication as well as multi-point data communication. It also supports the full duplex communication, so we can able to transmit and receive simultaneously. Like HDLC, there are other protocols. They are called as SDLC, ADCCP, and LabB. But our syllabus does not include these three. We can see the features of the HDLC. It is the most widely accepted protocol. It already told you. It has a high level of flexibility, adaptability, reliability, and efficiency. It is a bit-oriented protocol, so it's used but to stop plugs occurring in data. The flow control can be able to adjust, and Windows S can also be able to adjust based on our capability. So three important things you have to remember before going for HDLC. That is a primary station, secondary station, combined station, because we are using in communication. So these three we have to know it. And also there are modes available. We can see one by one. Normal response mode, that in short form we can call NRM, asynchronous response mode ARM, and asynchronous balance mode ABM. And also we have to know that there are three types of frames. One is U frame that can be named as unnumbered frame. Another one is information frame. In short form, we can call I frame. And third one is a supervisory frame. We can call also S frame. So already we seen about the three stations, right? So we can see one by one in deep. Primary station. It actually look the link management. That's nothing but it can able to command all the secondary stations. In case of communication between primary and secondary station, the primary station can able to provide the commands and what other was can able to do. So mostly the primary station will issue all the frames to the all the secondary station that were connected. And secondary station that will work under the primary station. Whatever the work given by the primary, they will be able to provide response only, so they cannot able to make any decision. That is called secondary station. And combined station, the station can able to act as primary as well as secondary. So they can able to decide or they can able to just respond. So it is called a combined station. It issues both, right? You can see the diagram here. In the diagram, first one is unbalanced mode. In the unbalanced mode, the primary station will be able to command to all the secondary stations that are connected together, and the secondary station can able to provide responses only to the primary station. They cannot able to take any decision. And the second one is a balanced mode. In balanced mode, we are using combined stations. So either the station can able to act as a primary as well as secondary in terms of communications. So that is said to be a balanced mode. And coming on to the three modes of transfer, the normal response mode. So here it's used for both point-to-point as well as multi-point configurations. The primary station will control all the overall management and everything. The secondary will only respond. If you go for asynchronous response mode, the secondary mode, in short form, we can call a ARM. Uh, the secondary station can transmit response without taking permission from primary station. They can able to respond like that. Okay. And third one. Uh, so why we are going for this NRM? In this NRM, sorry ARM. Uh, so everything they have to ask permission from the primary means it will take more delay or they can able to have overwhelming response, right? Overwhelming that. So without taking permission, they can able to uh, communicate to the primary as that's an hassle free, right? And third mode is an asynchronous balanced mode. Before I told you, they can use combined stations. So because of this combined station, they can able to either command or response to either of the station in balanced mode configuration. So here only the point to point can able to take care. There is no multi-point configuration can be done here. And the structure of your HDLC, I can see that the frame format, it consists of flag. So the flag of bit length will be 1 byte, that is 8 bits, and address is also 1 byte. Maybe if you need, you can extend, depend upon your memory space you connected, right? And then the third one is control. The supervised information we can able to say. So it consists of maybe 1 byte or 2 byte length. And the fourth one is information, it variable, so we cannot able to tell exactly how much length will be. And the last one is sorry, before last one, we are having FCS, that's a frame check sequence that may be 16 to 32 bits long. Uh, so 4 bytes you can able to have. And last is also flag, the starting frame and the end of frame, there will be a flag that is consist of only 1 byte. And go for the control field format. Already I told you there are three frame formats we are having: I, S, and unnumbered. That is the I, S, and U. In I structure, you can see that same. It's consists of flag, address, control information. Everything will be same like the general format. The space will be there. And second one, supervisory. Instead of information, okay, there will be no only the flag address control and frame check sequence as well as flag double indented. There is no information can be carried out in supervisory. Only the control fields. And third one is unnumbered. Here we can able to get the management link instead of information data. We can able to replace the management information. That is the third unnumbered frame. And we also see that the frame numbers, we can add the thing send sequence number, receive sequence number, S is equal to supervisory function bits, M is equal to unnumbered function bits, and the P slash F, that pole with final bit can be taken here. So already I told you about this. It consists of frames. So I told you the flag field is of unique 8-bit word pattern. So it's like a synchronous mode. The start and end of each frame and the field idle time between consecutive frames. I told you what is address field and control field. The frame check sequence, you can see that there are four types of S frames are possible here. If both the bits are 00, it corresponds that information that is we are ready to receive that frames. We can see that. If your SS is 01, it comes to reject frame, so which are used by receiver to second a negative acknowledgement when error has occurred. And if your SS is equal to 10, the receiver is not ready to receive all the datas. This is for flow control. Okay, so the receiver will be waiting for the information to be carried out from the transmitter. And if both the bits are 1 1, it's correspond to selective repeat frame. So if there is any frame has been lost between the transmitter and receiver, so they will be able to indicate that negative acknowledgement to the transmitter to repeat the say a consecutive frame transport here. And we are also having when the piggybacking, that's an included flow and error control information. So when pole with final and frame is equal to 1, the information will be carried from primary to secondary. And either if the pole with the final is 0, the information is carried out by secondary station to the primary. So students, this is about HDLC. Now you can know about what is HDLC, where we are using, what is the structure, and what is the protocol. Uh, so thank you for listening on this HDLC topic.